All right, here we go. So again, this is surface area. Surface area is harder than volume. The surface area is going to be made up of 3 different surfaces for this one. The wraparound cone, or the lateral area of the cone, the wraparound cylinder, or the lateral area of the cylinder, and then the base of the cylinder. So we need a couple things here. We need the height. We have the height of the cylinder. We have the diameter of the cylinder, which the radius is going to be 8. We have the true height of the cone that we can find by doing subtraction. 12 minus 20 is going to be, or sorry, 20 minus 12 is going to be 8. So what we can do is we can do the Pythagorean theorem to find out the slant height, or the lateral, the L. We'll call it slant height. So we go 8 squared plus 8 squared equals c squared, 64. Some of you are like, it's just a 45, 45, 90. We know it's just going to be 8 root 2. But some people didn't know that. I think I'll probably leave it in terms of root 2. But you can probably give this the decimal either way. You know the math. So if I want to find the lateral surface area of the cone, it's going to be pi times r, which we know is 8, times L, which is going to be 8 root 2. So it's going to be 64 pi root 2. I'll put a little underline there saying, hey, that's the lateral surface area. Try to keep my work organized. Erase this, box this. And then let's find the lateral surface area of the cylinder. So it's going to be 2 pi r. Sorry about that. 2 pi r, which is going to be 16 pi, times the depth, which is going to be 12. 16 times 12 is going to be 192 pi. I'm going to put a little underline on that. And then the last thing I need is the bottom, which is going to be just pi r squared. So the circle on the bottom is going to be pi times r squared. To find the total surface area, I'm just going to add those 3 together. So I'm just going to get the decimal equivalent here, 64. I guess you could do it like this, 64 pi root 2 plus 64 plus 192 is 256. And I cannot combine those terms. These are not like terms because one is root 2 and the other one does not. Oh, and then my units are going to be centimeters squared. Boom. 8. Paper towel roll. So the paper towel roll is going to be made up of the inside rectangle, the outside rectangle, and then the 2 donuts. So let's find the surface area of the 2 donuts first. So the inside radius is going to be 4. The outside radius is going to be 6. So the donut is going to be pi r squared, 36 pi, minus pi r squared, 16 pi. That's going to be 20 pi. Times 2, because we have 2 of them. So the 2 donuts are going to be 40 pi. You can play me at half speed if I'm going too fast, using little gears on the right. And then from here, let's do, this will be the outside rectangle, and this will be the inside rectangle. The outside rectangle is going to be 12 deep, and it's going to have a circumference of 2 pi r, which is 12 pi, so that's going to be 144 pi. Put a little underline on that. And then same thing here. This is going to be 12 pi, or 12, sorry, and this is going to be 2 pi r, which is going to be 8 pi, using these 2 radiuses. So 12 times 8, that's going to give me 96 pi. And then we add them all together. 144 plus 96 plus 40 gives me 280. 280, there we go. Pi millimeters squared. Boom. The old PTR, paper towel roll. Oh yeah, nice. So this one, again, surface area. So the surface area of a sphere is going to be, and think about it, there's actually going to be two surfaces. There's this surface here that I can touch, and then there's the bottom circle that I can touch too. So the surface area of a sphere is going to be 4 pi r squared. So that's going to be 4 times pi, better than that, 4 times pi times 64, which is 64 times 4, 256 pi. Then we have to divide by 2 because we want the hemisphere. So that's going to be 128 pi. Underline it, we're going to need it. Plus, we need to touch the bottom of the circle too. So the circle is going to be pi r squared. Put a little underline under that. The composite shapes are actually kind of easier than the regular shapes. 192 pi feet squared. There's a problem similar to this. Actually, this is a really nice that we have the lateral, we have the slant height here, which is really good. So there, again, there's going to be 3 different parts. And the nice thing about this is you don't have to worry about adding the base because you can't get in. If this were a solid block, you wouldn't be able to get into the base. So let's find the surface area of the top hemisphere. So it'll be 4 times pi times r squared. And then we're going to divide by 2 because it's a hemisphere. So 144 times 2 is 288 pi. Put an underline around that because we need it. The next part I'll do in green. So that's going to be the cylinder. So I have to find the circumference. And then tiny tower it up, multiply by the height. So the circumference is 24 pi times the height, which is 10. So that's going to be 240 pi. And then I need to multiply by, or add, the lateral area of the cone, which is pi times r times L, 13 times 12, it's going to be 156. And I just add all 3 together. So 288 plus 240 plus 156, 684 pi inches squared. Boom. One more. This shape is a cylinder with a hemisphere removed. Cool. So it's actually got an open top. So the radius of this thing is going to be 7. So again, this is going to be made up of 3 different surfaces. The inside hemisphere, the outside lateral edge of your cylinder, and then the bottom circle. So the hemisphere, let's do it real quick, is going to be 4 pi r squared. Oh, almost made a classic mistake saying the diameter and the radius were the same. But then I have to divide by 2 because it's a hemisphere. So 49 times 4 divided by 2 is 98 pi. Let's go ahead and add the lateral area of the cylinder. So the perimeter of the cylinder, also known as the circumference, is going to be 14 pi times the depth, 294 pi. Oh, I forgot to underline. And then the bottom circle is going to have an area of 49 pi r squared. Underline. Add them all together. 98 plus 294 plus 49. 441 pi meters squared. All right. There you go. That's surface area. Surface area is tougher than volume. So good job.